Okay, so now we're going to go ahead and pick up with ion formation. So some elements will gain or lose electrons to achieve their noble gas configuration. So remember the electron dot structure for each group shown below. Now these elements that gain or lose electrons, we call those ions, specifically cations if they lose electrons, or anions if they gain electrons. Because remember, electrons are negative. So if you're losing electrons, you get a positive charge. If you're gaining electrons, you get a negative charge. Also remember your electron configuration notations. Ion electron configuration notation is different than neutral element electron configuration notation. Because elements in groups 1 through 13 tend to give away electrons, they're going to have a lower electron configuration than their neutral. Elements in groups 15 through 17 tend to take electrons, which means that they're going to have a higher electron configuration notation than their neutral. And then group 14 nonmetals don't really tend to bond ionically, so we don't deal with them very much in this module. And this includes carbon. And then transition metals have many possible charges because of their D and F orbitals. So for example, here at this table below, you have your charges in your groups lined up. So group 1 usually has a +1, group 2 is a +2, groups 3 through 12, which are your transition metals, I just put in varies because it can be 2, 3, 4, 6. It just depends on that particular metal. And there's going to be a table for that later on, for ones that we'll commonly use. Group 13, we're mainly looking at aluminum, is a +3. Group 15 tends to have a -3 charge, 16 is -2, and 17 is -1. If you want to label your periodic table with these, definitely do that if you think it'll help you figure these out as you go. Okay. So let's look at some examples. Lithium gives away 1 electron. So the electron dot structure for lithium normally is Li with 1 dot. Its electron configuration notation is 1s2, 2s1. Its noble gas is He2s1. So let's look at what the ion does. The ion gives away that electron, and it just has a blank valence shell and a +1 charge. The electron configuration notation becomes just 1s2. And the noble gas notation becomes just He, because the whole point in giving away that electron for lithium is to achieve that stable helium noble gas configuration. Let's look at a different element, fluorine. Fluorine's normal electron dot structure has 7 electrons around it. Its normal electron configuration is 1s2, 2s2, 2p5, and its normal noble gas notation is He 2s2, 2p5. Now let's see what happens to the ion fluorine. Fluorine takes 1 electron, so now it has a full 8 valence electrons in its shell, and it has a negative charge. Its electron configuration notation is now 1s2, 2s2, 2p6, and its noble gas notation is just Ne, because again, the whole point in becoming an ion is to get that noble gas configuration. And this happens most often with those elements that are closest to those noble gas configurations, group 1 and group 17. And then as you go farther from those noble gases, you have to either give away more electrons or add more electrons. And so that's why those charges differ by column and by group number. Okay. All right, so we're going to go ahead and stop here, and I'll see you in the next video.